Today we will look into graphing quadratics with the b-values, with the vertex values. It's going to be a very short video. We will look into two examples. And we know the transformations work when we have the a value and b value and c value, where a value tells us to stretch, compress, and or flip the line. B value is going to show us a horizontal shift, so we're going to have to find that horizontal shift for the given b values, and we will find a new axis of symmetry. C value will give us the y-intercept. Here is our first example. To graph the parabola when b is not equal to 1, we're going to follow a series of steps. First thing we want to do is to find the vertex and plot it. Because vertex of parabola is where the axis of symmetry passes through, so we would need to find the axis of symmetry. For this example, we have our a value, b value, and c value. Let's write them over here. Here's a value, b value, and c value. A is 2, b is -8, c is 6. If I do negative b over 2a, negative of -8 over 2 times a, which will be equal to 2. X-coordinate of the vertex is 2. Let's find the y-coordinates of the vertex by plugging this 2 into the function. So y vertex would be equal to 2 times 2 squared minus 8 times 2 plus 6, which will give us 8 minus 16 plus 6, which is equal to -2. Now we have our vertex point as x2, y -2. I will start at x2, y -2, and then plot my vertex. Then our next step is drawing the axis of symmetry. Axis of symmetry has to pass through vertex, so this is our axis of symmetry. There is a series of patterns that we are going to remember from parent function. On every parent function, when we have x and y values, whenever x is 0, y is 0, of course. Whenever x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. When x is 4, y is 16. Now, because our graphs are tiny, we are just going to look at the first 3 in here, and we will use that pattern from the parent function, and with the help of that pattern, we will be able to figure out the points for this graph. Now, instead of having 1, 1, 2, 4, 3, 9, we will start with that pattern. We will put 0, 0, 1, 1, 2, 4, 3, 9 in here, and we will multiply each of them with the a value. Look at the a value in here is 2, so I will multiply each of the y values with 2. So I get 0, 0, 1, 2, 2, 8, 3, 18. Now, this pattern will help us to find the other points starting from the vertex. We must start from the vertex. Starting from the vertex, if I go 1 point away on the x-axis, I should go 2 units up. Let me repeat that part again. If I go 1 unit away on the x-axis, I should go 2 units up because of this pattern right here where x is 1 and y is 2. I will follow the same thing for the next one. This time I will go 2 units away from the vertex, and we will go 8 units up from your vertex. 2 units away, 8 units up is going to be right here. If I were to go 3 units away, I should have gone 18 units up. 18 is not going to fit. At this point, I need to find the reflection of the points over the axis of symmetry. So I will go over the other side and reflect find the reflection of the points by the axis of symmetry. Now I have enough points to graph my line, and we can just connect these points. Here we go. We are done graphing our parabola. To recap, we find the vertex, plot the vertex, use 1, 1, 2, 4, 3, 9 method, and multiply the y values to find the new y values, and move away from the vertex to find new points. Confirm that your y-intercept is the c value. So c value was 6 in here. My y-intercept is actually 6 as well right here. That's my y-intercept, c value. And I know that my graph was correct that way. Horizontal translation is shifting the parabola left to left or right, to the left or to the right. By the vertex values. In a parent function has the vertex of 0, 0. So any new vertex will have a different point. So that shows us that the graph will be shifted. When we are looking at the shift, we look at the x value of the vertex because that's going to tell us the horizontal translation. And the y value of the vertex is going to give us the vertical translation. As far as finding the vertex, we should know that x vertex can be found by negative b over 2a, and the y vertex can be found by plugging x vertex into the function. Let's look at one more example. Our goal is to first find the vertex, then we will draw an axis of symmetry, and we will decide if it opens up or down. We will create our pattern and multiply each y value with the a to reflect additional points, and we will find these points, reflect them by an axis of symmetry, and confirm with the y-intercept, and we are done with the parabola. Let's label our points A, B, C, and x vertex is equal to negative of negative 2 over 2a, which is equal to 2. Y vertex 1/2 times 4 minus 2 times 2 minus 3, which is equal to negative 5. So we found our vertex as x2, y negative 5. My vertex is going to be x2, y negative 5. Now, we know that a value is greater than 0, so parabola is going to be opening up. Let's not forget the axis of symmetry as well. Axis of symmetry is going to be right here. As the next step, we're going to create our pattern 1, 1, 2, 4, 3, 9. We have 1, 1, 2, 4, 3, 9. If I were to have another value for this one, such as 4 squared is 16, so 4, 16 would be the normal one. And because we are multiplying each y value with 0.5, I multiply this one by 0.52, and we will get 8 for this one, and we will get 4.5 for this one, we will get 2 for this one, we will get 0.5 and 0. So that's these are the y values. Starting from the vertex, I will go 1 away and 0.5 up. Then we will go 2 away and 2 up. This is where I got my numbers. 1 away, 0.5 up. 2 away, 2 up. 3 away, 4.5 up. 3 away from vertex, 4.5 up as approximate as possible. Change color. And 4 away, 8 up. When I have 4 away, 8 up, all the way up here. I can find the reflections by using the axis of symmetry, this one, right here, and the next one. We are ready to graph the parabola. I can connect my points to graph the parabola. Check that y-intercept is the 0c value. 0c value is -3. And yes, our y-intercept is -3. As you can see, y-intercept did not give us the horizontal shift or the vertical shift. We can get the horizontal shift and vertical shift by looking at the vertex. This tells us 2 in here. It tells us go right 2 units. And this tells us go down 5 units. From the origin 0, 0, our parent function has been shifted 2 units right and 5 units down. Now, if you have an internet access, you can go to desmos.com and try to graph 2 parabolas where you will have a vertical stretch on one of them and compression on the other. Think about what kind of values you can give on your A, B, and C values for vertical stretch and compression. Which one is important? Would you be changing the A values, B values, or C values to reflect or to make an effect on vertical stretch and compression? Find 2 equations and graph each of them in this website and compare the appearances of parabolas. How does it affect the appearance of the parabola if you have vertical stretch and vertical compression? If you have your own calculator, you do not need to go to this website. Just use your own calculator or use your own graphing calculator. Let's do one last summary. We will have vertical stretch when absolute value of leading coefficient is greater than 1. That's absolute value of A greater than 1. We will have a vertical compression when absolute value of leading coefficient is less than 1. Absolute value of A is less than 1. Reflection happens if A is less than 0, when A is negative. Translation, when the function has a constant value, it will shift up, down, left, or right. And for translation, we will look at the vertex values. Axis of symmetry, the equation of the line is going to be Vox style. So x is equal to number is the axis of symmetry, and it will always pass through the vertex. Vertex is the maximum or minimum of the quadratic function. Also, let's repeat that part one more time. Vertex will give us the translation as well. Vertex will give us the translation of shifting up, down, left, or right. And x values will tell us left or right. Y value of the vertex is going to tell us to go up or down. That's pretty much it. In the class, we have plenty of examples on different styles, and we will go into a little bit more detail.